Welcome to Chapter 6. So far, we have dealt mostly with rather dense crystal structures. For example, we have analyzed the crystal structure of benzene. Here, the molecules are packed tightly. There is no open space. One ring of benzene lies close to the next one. The distance between this ring and the one on top is about 4 angstroms. And this is very typical for solids. Usually, the space is completely filled. This week, we take a look at structures in which empty space plays an important role. This compound is different. It is a so-called metal organic framework, or short MOF, MOF. We also see aromatic rings, like the ones in benzene. But this time the structure is much less dense. There is even some empty space. Look here. The distance from this aromatic ring to this other one is about 12 angstroms. That is 3 times more than in the benzene crystal. The difference between those two structures lies here. Obviously, there is something holding the benzene rings apart. Compounds like these are porous. You can think of them as sponges with very tiny holes. In most MOFs, these holes are typically 5 to 30 angstroms in diameter. And it's this existence of holes that makes the MOFs special. Because if we consider the surface of such a MOF crystal, we not only have to take the outer surface into account, but also the inner surface generated by their pores. The specific surface area, this means surface per mass unit, of MOFs can be extremely large. It is not uncommon that a single gram of MOF crystals, like this little pile you can see here, has a specific surface area of several thousand square meters. For comparison, a basketball court is 420 square meters large, and a soccer or football field is about 7,000 square meters large. Typical values for MOFs lie somewhere in between those values, and again, that is per gram. This feature, along with their structural diversity, makes them very interesting candidates for many applications, such as gas storage. A very big chemical company manufactures them on a large scale and examines their properties as a storage material for natural gas. There is an excellent video by Chris Wilmer about this matter available on YouTube. We find it very instructive. Take a look at it. Explaining all the possible applications of MOFs would constitute a MOOC on its own. But of course, we will provide some information on them in the References and Resources tab. In this chapter, we will explain some general structural features of MOFs. We will start the next unit with the question, why are they even called metal organic frameworks?